In this video, we're going to review how to find the centroids of complex shapes. So, if the complex shape can be decomposed into corresponding simple subshapes, then we can use what's called the composite parts method. So in this technique, we say that x bar, which is the centroid of the entire shape, is equal to the summation of xi bar times ai over the summation of a sub I, and y bar, which is the y centroid of the entire shape, is equal to the summation of yi bar ai over the summation of a sub I. Now, what are these variables here where we said ai is the area of the composite shape or subshape or slash part I, and xi and yi are the coordinates of the centroid. These are xi bar and yi bar of the centroid of part I. So I've drawn an example here. This is our example that we're going to look at. So here we have a rather complex shape, which has a sloped right side and then sort of a notch taken out on the left. And so we can break this up into three subshapes or three parts, and then find the centroid of each of those. And so what we're going to do, we're going to say that this part on the left here, we can break that up into a triangle, and we're going to call that part 1. Part 2 is going to be this entire square. We're going to include the part that's not there, and that's going to be part 2. And then part 3 is going to be this part that we're going to subtract out. So this is part 3 right here. So when you have a negative space like part 3, you can subtract out that part right there. And so what we can do then is use this method of this composite parts method, and basically find each of these parameters for each of these parts. And so I'll write down parts 1, 2, and 3, and we'll have a row for each of those parts. And so we'll go through, we'll find the area of each of these parts. So the area of part 1 is 1/2 times 3 times 3, which equals 4.5. The centroid of part 1 is 1 meter. The centroid in the y direction is also 1 meter. That's 1/3 in both directions. Now here we have xi bar times a, so we're just multiplying those two together to get 4.5 and 4.5. So that's part 1 sorted. For part 2, we have this entire square. So we have 3 times 3 is equal to 9 meters squared. The centroid of this part is just the center, negative 1.5 in the x direction and positive 1.5 in the y direction, because it's a square of 3 by 3. We can multiply those out. We get negative 13.5 for xi a and 13.5 for yia. Now for part 3, this is the thing to remember here, is that this is a negative space, and so we're going to subtract for a negative space. And so we'll put a negative here, and the area of this part is 2 times 1 meter, so we have -2. The centroid of this is -2.5 in the x direction. It's 2 in this direction, and then since it's a rectangle, it's the center, so it's 2.5 here. In the y direction, and the centroid is 2. It's not really drawn to scale. So multiplying this out, we have -2 times -2.5, we get 5, and then we have -2 times 2, which gives us 4 here. So now what we can do is we can sum up the relevant parts here. So we have the summation of A is equal to 4.5 plus 9 plus -2, which gives us 11.5. And then we also want to sum up these two terms here. So we have the summation of xi bar ai, which gives us -4, and the summation of yi ai is equal to 14. So that gives us everything we need to fill into these formula up here, the x bar and y bar. And so we will write that down now. So x bar is equal to the summation of xi bar times ai over the summation of ai is equal to, and here we have -4 divided by 11.5, which is equal to -0.35 meters. And y bar is equal to the summation of yi bar times ai over the summation of ai, which gives us 14 divided by 11.5. So that tells us that the y centroid is located at 1.22. So the x centroid is located a little bit to the left here of the y-axis, and the y centroid is located at 1.22 meters above the x-axis. So that's how you can find the centroid of a complex shape using this method of composite parts.